Yeah, good afternoon, everyone. Yeah, thanks to our communication manager. I don't know how to make this kind of slide. Yeah, so maybe to start by saying this is a follow-up research that we are doing. We firstly, in between 2019 to 2021, we did a study on the red list of ecosystem of coral reefs in the Western Indian Ocean. And the results show that Kenyan reefs is vulnerable to collapse. So now we are doing at a national level to be able to inform the possible solution to recover these reefs. And for now, I'm doing this with my team from my organization to understand the patterns of those hard coral reef, including the recruits and the adults, in order to inform the people who are experts or are intending to do restorations in Kenya. And then we have also concurrent research, which is also looking at the connection, the connectivity between different reefs, the larvae and movement. So I'll skip the author. And they use the old slide. I changed. Yeah, so this is just a research question from this preliminary analysis. The research is still ongoing, and we are still collecting more data to feed in. So on our method, we use the normal underwater visual sensors, where the divers they go inside the water and are collecting the data. And when we go inside, we have a different team. We have the fish team that they do collect the fish diversity, the abundance, and also calculating the biomass. And then we also have other team that is collecting the benthic cover, and then others they're collecting the adult corals, and others we do collect the coral recruits to see that relationship and how we can be able to inform those intent to do restoration in Kenya. We are not actively involved in restoration, and we have no expertise on that, but to be able to provide those ecological recommendations. So our preliminary result on this one, what we saw first is there is significant difference in terms of recruit density across different locations on our reefs, which when you see on the end of that side, we have a Kisite Marine Park. So Marine Park in Kenya these are the no-take areas that are being managed by the government, and we see they had a lot of reefs, about 10 per square meter, while in the area like Likoni, which is in the central of Kenya, they have around 1.2. So it's a big variation at different reefs. So we also try to check between the inner reef and the outer reef, and also between the management regime, and we did not see any significant difference between them, and the recruit density were almost similar. So we also try to see how these recruits. So for the recruits, we consider the recruits with the diameter size of 10 centimeter, that is less than 10 centimeter, and if it is more than 10 centimeter, we consider it to be adult. And by looking at the density, I don't know how to point. So in the green line, we see the density is increasing as the size of the colony increases, while the area on the recruit side, the area is increasing, but on the adult side, the area is going down as the size of the colony increases. And then for the relationship between different communities found between recruits and adults, we see there's high correlation between the genus in the recruits and the genus in the adult, but with a very few like Platygyra and Favia, which shows to have more adults than recruits, which may indicate that if these adults do die, there may be no recruits to replace them. And as well, when you look at Pavona, we see it has more recruits but less adults. So may mean that they're not growing into adults. There's kind of threats. And also we try to see in terms of the genera, which we consider to be thermal resistant, and genera that we consider to be thermal sensitive. This category we got from the other research done by Tim McLanahan. And we see that where we saw at Kisite Marine Park was, it was the site which had high recruit density. but it was dominated by the sensitive coral. So in case of thermal changes, it means it will be very easy and it can be wiped out again. This is just the normal correlation to see different categories of benthic and other. And what we see here is most of the sites that had higher recruits, they were corresponding to high hard coral cover, low microalgae cover, and high herbivore. Okay, I've been told my time is out. So, okay. So my conclusion is to say the recruit pattern are significant difference along the different reefs in Kenya, and there is enough recruits we can say that they can build on the population. So the most of the problem we have is those threats, so that we can allow those recruits to grow into adults, and also there's a consistency in terms of the coral community from the recruits to adults, and microalgae dominated location with few herbivores, and they have a low liquid density. So moving forward with this research now, as I mentioned earlier, we'll try to first to understand the current level that we have with the historical data. We have sent email to different organizations if they have the historical record data, so we can see is it normal or is it changing. We are also will also use the other project from the connectivity of larvae to also to see this relationship and be able to inform on the restoration from the sites that we can say that the source of recruits and the sites that we can say at the sink, and where and which sites we may need active restoration. Just to acknowledge different contribution from different organizations and funding. Thank you.
Thank you very much. I think we have time for one question while we're changing over